Welcome to the second half of 7.6. Specifically in this video, we're now going to talk about work and rate problems in terms of rational applications. Now, this problem, notice I have Ronaldo who can paint a house in 9 hours. His brother Carlos can do it in 8. How long does it take them to paint together? I just want you to use some logic. I want you just, without doing any equations, I want you to think, what time kind of makes sense? Take a moment, just think about that. Now, let me ask you a question. Did you say 8.5? Now, let me tell you why that's not a good answer. 8.5, a lot of people get that because they just take the average of these two. But if Carlos can do it in 8 hours by himself, why would it take longer if Ronaldo's helping him? Unless Ronaldo's a little kid. I have little kids, they totally slow me down. Total sidebar. But the big point here is, they're working together, so it should take less than 8 hours. It should take a lot less. So how we get our answer is actually we're going to have to create a rational expression. And to help you kind of see how that would work, it's actually based on a few different things. So let's just make a table to see how these all work together. So first, let's look at time per job and their work rate. So rate is going to be a big part of this. So if we have Ronaldo, how much time does it take him to paint a house? 9 hours is given information. Well, if he can paint a house in 9 hours, how much of a house does he paint per hour? Well, he paints 1/9 of the house per hour if he takes him 9 hours. What about Carlos? Can you fill in this table for Carlos? Well, he can do it in 8 hours and takes him 1/8. What about together? How long does it take him? That's the thing I don't know. It's X, right? But if it takes them X hours to do it together, what's their rate? Isn't it 1/8? Well, with all this in mind, we now can actually make an equation because work rate, time does not add up linearly because of rate, the way rates actually apply, but rates do combine in this manner. So it would actually take him 1/9 plus 1/8 because his rate plus his rate is their total rate. So that's how we get this equation right here by adding up the individual rates. So can you solve this for X? Go ahead and solve it. Pause the video and solve it. Well, hopefully as you did it, first thing, what's my lowest common denominator? It's 72x because none of them have anything in common. So if I multiply everything by 72x, I'm just going to skip ahead on all the distribution on this portion. 72x is going to end up giving me 8x plus 9x. So I multiply this by each of the terms. Equals 72. Add those together. And we end up x equals 72 over 17. So it takes them 72 over 17 hours together. Now, if you're kind of curious about how much time is that? Well, 72 divided by 17 is larger than 4, but it's smaller than 5. So it's somewhere between 4 and 5 hours it takes them to do it together. But this is being exact because that's what we do in this class. Well, we can do more than just work problems. We can also deal with problems that are dealing with speed. So I have a plane. It's flying at a constant speed in 2 different directions. But the wind is affecting it as it goes in 2 different directions. So I want to find out what is the speed of the airplane. So going back to even what we've done before, what's the thing that I'm looking for? Well, it's the plane speed. Or you make that 2 words, it's your choice. Now can you make a table like we did before where I have distance, rate, and time, and specifically I have it with the wind and against the wind. So go ahead and just make a table like this based on the information you have. All right, well, direction, we know that not direction, distance with the wind, it says she went 810 miles. What is her rate? Well, if the plane is going p miles per hour and the wind is 15 miles per hour, wouldn't that be p plus 15? And the time, I don't know, so I'm just going to say t. Against the wind, 720, and the rate is p minus 15. Again, we have a t. Okay, So I have this nice table. I'm still not sure what to do with it. Remember, we have this thing that distance equals rate times time. So we could plug those things in, but wait a second. Can you solve for t? Can you solve this equation so you have t on one side and everything else on the other side? Yeah, you can divide it by r. And so we get t is equal to d over r. Wait a second, I can use that. So I can write t, so with the wind, I have this first equation of 810 divided by p plus 15. Are you okay with that? I'm just using this equation right here, plugging in the values I have. Same thing right here. But wait a second, if t is equal to t, can I just substitute in this for t in the other equation like we did when we had a system of equations? The answer is yes. The truth is this is a system of equations. It's just not linear. So not all the techniques work, but substitution we can definitely do in this particular case. If I substitute, notice I have this. That's a whole lot nicer. So let's just focus on that equation. Can you solve that equation? Go ahead and pause the video and solve it. Well, as you did it, we can cross multiply or we can multiply by lowest common denominator. In any case, we get this, multiply it out. Be very careful as you're doing all your multiplication. Make sure it's clear. We add the 12,150 both sides, and then we subtract the 720. Obviously, I made an error right there. I subtracted first, and then I added the opposite order. So we get 90 equals this, divide by 90, and you get 255. So the plane speed was 255 miles per hour. Okay, and does that make sense? Think about it. Does a plane going 255 miles an hour sound right? It does to me. All right, last example that I want you to work through is I want you to try doing this one, doing this whole distance rate. You might want to make a table, work with it, try it. Go ahead and pause the video and work through this. All right, as you work through it, first off, Jenny's speed, we'll just make J, and M is Mary's speed. Spief. And then notice Jenny drives 12 miles per hour faster than Mary. So what if I said that, I don't know, Jenny is equal to Mary plus 12? Isn't that what that means? Okay, now we just fill out the same table. Distance, rate, time. Mary, distance. Well, she drove 175. We just said it's M, and her time is, I don't know. Mary is, Jenny would be 225, M plus 12, and T. Now, can you set up some equations based on what we've done before? If you didn't get to this point in time, can you set up all that to make some equations? Yeah, in fact, we can do the same thing. Solve and T is equal to D over R. So if you plug those in, we get 175 over M and 225 over M plus 12. Again, we can make them equal each other, and then we just have to solve this equation. So if you didn't get to this point in time, get here and go ahead and pause the video and solve that equation. All right, now as you solve it, we can multiply, distribute, we can move the minus 7175 over the other side, divide both sides by 50, and M equals 42. But we're not done because notice it asks for the average speed of both. So what is Jenny's speed? Well, Jenny is M plus 12, which is 42 plus 12, or 54. So that means that Mary drove 42 miles per hour and Jenny drove 54 miles per hour. And that should make sense. Driving going 80, 90 miles an hour probably is not realistic over a long period of time. So look for these things, kind of use them to your advantage. Does it make sense? And the same questions we asked way back into our first applications, again, ask the same questions. It applies to everything. Just keep using it over and over. Good luck, and let me know what questions you have.